Yeah. All right, guys, let's get started. Okay, so today we're doing a new section which doesn't feel a lot like maths, but it looks probably like your programming modules. Do you guys start with binary and stuff like that in any other module?
We know the concept of binary.
Yeah.
All right, so this section is for counting and data representation. Well, we've done the counting part already. Now it's data representation. And the first thing, again, guys, I'm a maths person. I don't know why they got me to teach this stuff. I really don't like this stuff. So we're going to try and learn it together, right? This is not my specialized area. Okay, anyway, the first thing we're going to learn is, of course, we all know that computers communicate in binary. They process in binary. This we know. Now we need to understand firstly that binary is just usually it comes from something in nature, right? Zeros and ones are not exactly in their raw form in nature, but zeros and ones just represent two polarities of something. But it could be something like a magnet with north and south pole, or a wire with current or no current. As long as you have two different things that a computer can recognize, we have the possibility to make binary, right? And there are other options as well. You don't have to use binary, but apparently binary is the easiest to work with because it's easiest to recognize two states distinctly, right? And I think the most commonly used one is something like a wire with either low current or high current. So I'll give you an example of what I mean, right? Again, this is going to be very crude, but let's suppose you press the A key on your keyboard, right? And that is somehow indirectly linked to 8 wires, right? Indirectly, okay? So I'm going to draw them here like this. 1, 2, 3, 4, 5, 6, 7, 8. And those 8 wires are connected to something, some kind of a decoder system, right? And now in these 8 wires, when you press A on the keyboard, it triggers certain of these wires to have current and certain to not have current, right? So in other words, it just supplies current to certain wires here. In physics, how do you guys represent current? Is it I?
Yeah.
I, right? So I'm just going to write I here if a wire has current. So suppose we press the key and it puts current in just these wires here, just for example, and the others don't have current in them, right? So this is where the shortcut idea of binary comes in. So anything with current, we may represent it as a 1, right? It means something's happening. Anything without current, we may represent as a 0, right? So I'll just fill this in here, right? And this is where you get binary information from, something like this. And in our decoder system, whatever that may be, it tells the computer screen that if you see this input here, display the letter A on the screen, right? So very crudely speaking, that's how these things work. It comes from something in nature which you can control as either on or off. That is recognized as a 0 or 1 by the computer, and that's how we transmit information. Usually in terms of, is it still called a GUI, where you then can represent things graphically, right? Yeah, okay. All right. So anyway, you guys will probably learn the details of this better in other modules. Here we delve more into the details of binary. Okay, so this red box here is a long story, but basically telling us that the word bit comes from the word binary digit. Have you guys heard of the word bit before? All right, so it's just something that's a 0 or a 1, right? That's a bit. Okay. All right, so everything we looked at in this example above, all of these are bits. Something that can be a 0 or a 1. Okay, so now let's try and get into something that looks a bit more mathematical. Okay, so now this famous expanded form is going to come back. So we can try to make a comparison between what we know and what we're trying to learn. And what we know is decimal, right? We all know how to count in decimal. Decimal is what we usually use where we have base 10, meaning we count from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Once you get to 9, you have to increment to the next digit and go to 10. And from there, increment the first digit again, 11, 12, 13, 14, so on until you get to 99. Then you increment the next digit, right? That's decimal. I'm saying it in a weird way, but we all know how to count in decimal, right? We all know how to count is what I'm saying. Okay. Okay, did I lose anybody here? Counting in decimal. Okay. If we lost here, then we're in trouble. Okay. So we all know how to count, right? Can you guys confirm that? You guys are stressing me out? Okay. All right, so we all know how to count. And now using the concept of how we understand counting in decimal, let's transfer that thinking to binary. Right? In decimal, we have 10 options. In binary, we have only 2. But it's the same idea. I want you to see that. So before we get into the formality of how to use formulas and stuff, let's just think intuitively. Right? So suppose I have how many digits? Let's work with 3 digits in decimal. Okay. So I'll start with 0, which you can write as 0, 0, 0. Right? Just because I'm using 3 digits, I want 3 placeholders at all time. So therefore, if you count in decimal, you guys know what to do here. I'm just going to demonstrate. The first number after 0 is 1, then 2, then 3, right? We get the point, and so on up until 9. Right? And once you get to 9, that's the maximum we can go to for this place. Right? So then we start incrementing. So then we put a 1 here, and we start re-incrementing that 1. So this will then become 0, 1, 0, or what we know as 10, right? Then we just redo what we did above, but now keeping this 1 here, right? The same thing happens again. So 0, 1, 1, 0, 1, 2, dot, 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 all the way up until, now this goes all the way up until 0. Okay, let me just do this, 0, 1, 9. Then we re-increment this one here to 2, right? Okay, let me not jump where we can't see. Let me do it here. So then we go 0, 2, 0. And then the same story again, 0, 2, 1, 0, 2, 2. And we keep on doing this up until we hit 0, 9, 9. That's the final point we can get to here. And the same thing again. Then once we hit the 9 and the 9 here, we have no more places to go with either of these. So we increment the third place now. And you guys probably think I'm wasting time here because this is obvious. But when I do this in binary, people start getting confused. So just keep this way of thinking in mind because it's nothing different. Just that we're so used to this in decimal, we don't even think about how we do it. But in binary, we have to reapply our minds to think about how it happens. So let's make a line here, and on this side, we will do it in binary. Okay, so maybe I'm going to use 4 digits here because binary increments much quicker. So instead of 3, I'll use 4 placeholders. 2, 3, 4. Okay, that's 0 in binary. If I want to go to 1, 1 is allowed, right? Because in binary, we can go to a maximum of 1. So 1 is allowed. So writing 1 in binary is not a problem. But now a 1 is, loosely speaking, it's like a 9 because it's the maximum. Right? So once you hit the maximum, remember what we did before. When we hit a 9 before, we then increment the next digit. So that's what we have to do here. Once you hit the 1, you need to then increment the next digit and reset the first one to 0. It's just that it's weird here because it happens so quickly because we only got 2 digits to work with, right? So this is now equivalent of updating the 9. And the next thing is we can increment the first digit again. All right, so keeping the second digit as it is, the first digit then becomes another 1. Right, but now this is already, it's like a 99 now because this is the maximum we can do here. So then we increment the next digit, 0, 1, 0, 0. Right, and now we repeat what we just did, but keeping this 1 here. So everything done above will be redone, but now with a 1 here, right? It's like when you get 100 and you recount, but keeping the 1 there, 101, 102, so on, right? So we just redo, in case anyone can't follow this, just remember the repetition helps, right? So from here, 0, 1, 0, 1, right? That's like 101. Notice this part here is going to repeat for the first 2 digits. Okay, so then you get 0, 1, that's like a 9, so then this will become 10. Okay, then after this thing starts confusing me already, 1, 1, 1. Now this is like a 999. Did I miss one? Okay. All right. So then this then becomes 1000. Okay, and now counting like this has an advantage because everything we did has a corresponding number in decimal because we went in order, right? So the first one here in decimal is going to be 0. The second one is 1 in decimal, that's 2 in decimal, that's 3 in decimal, and so on. 5, 6, 7, 8, and so on. So this is useful initially for the first few numbers, but if I were to ask you to, for example, write 57 in binary, it's not practical to count all the way to 57. That will take a while. So we'll have to learn new techniques. Sorry? That is a part of the method. Yeah, that is one method. Right. So again, you guys can try counting in binary at home. This was just to give you a little flavor of how the thing works. I know it can be confusing though. Okay. Are you guys all okay so far? So you don't have to know this off by heart. This is just to give you an idea of what we are doing here. Okay. Now let's try and do something a bit more formal. So unfortunately, we have to get back to this expanded form here. So I'm going back to the one in decimal first, the one we know. I was going to say know and love, but I don't know because this is where all the marks come from. But anyway, that's not the point here. The point is that if you have a number like this, for example, 90328, we know how to write this in expanded form, right? We've seen this before, writing it as 90,000 plus 300 plus 20 plus 8, right? The first line, are you guys all okay with that? It's first line above. From the first line to the second line, this one here. Can everyone see what's happened there? Yeah. Okay.
I don't want it to be back yet.
But you get it. Okay.
Yes.
So we've just essentially taken out the powers of 10 here. Right? That's what we've done here. And we write as something multiplied by a power of 10. And in the next step, we just do that a bit more clearly. To clearly write at the power of 10. So 10,000 is written as 10 to the 4, 1,000 written as 10 to the 3, and so on. We're just clearly writing the powers of 10 here. Right? And we're not doing this for nothing because this will help us in binary. Okay. But up until this step, everyone clear? What's happened? Okay, that's perfect. If you guys are there with me, then binary is not going to be too difficult. Now, using the same idea, using exactly the same idea of expanded form, if the screen will let us, we need to convert this number, just an example, convert a binary number back into decimal using expanded form. An expanded form in binary is exactly the same as in decimal, except now we're using base 2 instead of base 10. So I'll show you what I mean by that. So let's do this example. Convert the number 100101 into decimal. All right, we're using expanded form to do that. Okay. Firstly, can anyone look at this number and is it obvious to anyone what number this represents decimal? Right? When I say obvious, I mean like immediately obvious. I know we can probably work it out. Okay, so that's okay. So now let's work it out formally. And I'm going to show you guys a method that we always use that always works. So I'll start by opening a bracket and I'll write this 1 times 2 to the power something. That's something, we just leave it blank for now. We'll fill those in later. So this 1 comes from here, from the first digit. Right, I'm just putting the first digit there and write times 2 to the something. That's something, I'll leave it blank. Yeah, and I'll keep doing this. Now I'll say plus again. Then I go to the next digit here, which is a 0. Right, so I'm just going in order. 0 times 2 to the power something. We'll leave the something blank. Doesn't matter. Always 2. Yeah, always 2. I'll just keep on doing this, right? After that, the next one is a 0 again. So I'll write the same thing again. 0 times 2 to the something. Okay. After that, the next one is a 1. So I'll write 1 times 2 to the something. Okay, and then I'm just going to fill in the last two, which is 0 times 2 to the something plus 1 times 2 to the something. This thing will, I can just die. Oh, okay. 1, where were we now? 1, 0, 1 is the last one. Okay, before I go any further, let's just make clear what I did here. Everything I wrote just comes from here, right? So the first one is 1, I write 1 times 2 to the something. Next one is 0, I write 0 times 2 to the something. There's another 0, so 0 times 2 to the something. Then a 1, 1 times 2 to the something, and just go in order like that. Everyone okay with that step? Okay. Where did I lose you guys? I'll just explain that again. Right? Okay. All right. So this form here, we always write something times 2 times 2. Everything is times 2, right? That doesn't change. Where these numbers in front come from, the 1, the 0, the 0, the 1s, is just from here. The first one's a 1, the second one's a 0, third one's a 0. I'm just copying exactly what's there. And times 2 is just always something we put after each one. Right? That's just the way we do it. It's just something to remember. But these numbers in front, they just come straight from here. The ones and the zeros. Okay, in order. 1, 1, 0, 0, 0, 0, so on. Okay, you guys with me? Okay. Now, the last step, which I should change color for, let's make this blue, is to just list powers starting from 0 here. So this will be 2 to the 0. Right? Start from 0 here. The next one will be 2 to the 1. Then 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5. Just start from 0 and go up. Right? 0, 1, 2, 3, 4, 5. Always in order. Right? Okay. And this is essentially the hard work done, because now this is the number that if you put into your calculator, it will give you the answer. Right? Whatever answer we get here is the decimal version of this number. So this at this point is just calculator work. We can check what that is. I'll check that for you guys. Okay, you got it. 38. Thank you. Okay, so we got 38 for that. So this is 38 in binary, is what that's telling us. You guys want to try another example? Get used to it. Let's do another one. Okay, I'll leave that on the board so you guys can look this one up while we do the other example. Okay, let's say convert 0, 1, 1, 0, 1 into decimal. Okay, let's try that one. Yeah. 37. Oh, sorry. 37. Okay. I'll just change that. Okay, thank you. Conflict, let me just double check it myself. Yeah, I'm also getting 37. You're still getting 38. It's possible that usually the mistake comes from the last one because that's a one, not a two. Anyways. Okay, guys, let's have a look at the answer. Okay, so I'm going to make space here and do it in the same place that we did the first one. So I'm just going to take all of this out for a moment. Okay, so guys, remember, if anyone's getting confused, just remember this is basically just expanded form. It is expanded form, but using base 2. Right, that's all it really is. So the example we're doing now is, just going to make more space here. So 0, 1, 1, 0, 1. So let's take this out. Okay, so I'm going to start with the same setup we did before, which is to just write every digit times 2 to the something and leave the something blank initially. That's all right. So we'll start. The first digit is 0, so I'll write 0 times 2 to the power something. Second digit is 1, so 1 times 2 to the something. Then we have another 1, so 1 times 2 to the something. Then we have a 0, 0 times 2 to the something. Lastly, we have a 1, 1 times 2 to the something. Right, quite a straightforward setup. And then again, now we start pulling in the powers of the 2, starting from 0 on the extreme right and working up as we go left. Who's right there? That's your right as well. All right. So starting with a 0 from the extreme right, 0, 1, 2, 3, 4. Right. And we'll soon start being able to take shortcuts with this, right? Because now we're just pulling everything in excruciating detail. But you guys will realize everything which has a 0 in front, it doesn't actually exist here. Right? It's 0 times something is just 0. So these terms, whether you write them or not, doesn't matter. That one, they don't contribute anything, right? I'm writing them so that when we're pulling in the powers of 2 from 0 all the way up until 4, we don't miss any. That's the only reason why I include everything here. But if you want to, when you start getting more used to it, you can skip that part. Okay, and you'll notice that now, excluding those terms, this is the same as 2 cubed plus 2 squared plus 2 to the 0. Right? The ones don't contribute anything. Really, they're like placeholders to show us where we are. So 1 times 2 cubed is the same as 2 cubed. And at this point, we don't even need the calculator. At least I don't think we do, because 2 cubed is just 8, 2 squared is 4, 2 to the 0 is 1. So that's 13. Okay. Any questions, guys? Okay, so this is the section where we can back up our marks, because the next part gets a little bit more tricky. Converting from Binary to decimal is the easy part because it's just expanded form. Decimal to binary is a little bit more tricky. I'm supposed to teach you guys two methods to do this. Well, one in particular, but one is a lot easier. And you guys might have done it in high school, I think, where you divide each number by 2, look for a remainder. We have done something like that. Okay.
Yeah.
All right. So that's perfect. Okay, but before I do that, let me just make sure you guys, I'll give you guys a minute to write this down, digest this, ask questions if you need to. And guys, today the work is a little bit involved, and also we are well ahead of the syllabus. So if you guys want, what we can do is I can work all the way up until 11. At about 10 past, we can just stop there for the day. But that's only if we don't take a break. So we'll see how we're feeling. Right? Okay. Maybe even 11. If we push to 11, we'll see how far we go though. We'll see. Let me saying all this on the video. Okay, the next part is to convert from decimal to binary. Yeah, sure. No problem. Anyone else still writing, taking pictures? Anything?
Yeah.
Okay. Well, now converting from decimal to binary, we need to kind of go in the opposite direction. We need to find a way to express 75 as a list of base 2 numbers. Okay, so this is how we will start that. Start with the blue. So we start by just listing out the base 2 numbers. If we can do it by inspection, it's better. If not, there's a method to use. So we'll list out the base 2 numbers like this. 2 to the 0, 2 to the 1, 2 squared, 2 cubed, 2 to the 4, 2 to the 5, 2, 3, 4. Not sure how many we need. We'll just list a few out. Just 2 to different powers. So I'll show you in a moment why we need it. Okay, so now it's useful to know what each number is. So above the numbers, I'll write what the actual number is. So what I mean is 2 to the 0 is 1. 2 to the 1 is 2. 2 squared is 4. Then we get 8, 16, 32, 60. Is this right? 1, 2, 4, 6. That's fine. Okay. All right. And guys, my brain is not functioning. What's after that? 2 to the 7? Anybody? 128. We need more than that. I think that's enough. So as a general rule, we need to go up until we pass the number that we're using. So converting 75, we need to go 1 past that. 64 was too small, so we go 1 more.
Okay.
All right. Okay, so once we're here, we start by you find the lowest base 2 number, sorry, the highest base 2 number, which is lower than 75, right? 64, right? So I'll write that down. That's the first number on my list, 64. The highest base 2 number lower than 75. So then we take our original number, 75 minus 64. And my brain doesn't work for these. It's either 9 or 11, but my brain is not telling me. It's 9, right? Yeah. So my brain doesn't know which way to go with these. 1 up or 1 down.
Yes.
It's 11. Yeah, someone told me 9. Someone has the same problem I have. That's nice to know. Okay. You guys are insulting him and me at the same time. Okay. So now this thing is repetitive. We keep on doing this, and I'll show you guys how we know when to stop. So first was 75. We found the first number lower than 75, which was 64. Our new number is 11. So in 11, we do the same thing. The first number on the list lower than 11 is 8, right? So we keep doing that. So we list that number, that's 8. So then we take 11 minus 8, which is 3, right? You guys are scaring me. It's 3, right? Okay. All right. Okay. And now we do the same thing again with our answer. The first number here, or the biggest number which is smaller than 3, is 2, right? It's 2. Yeah. Yes, it is 2. Okay. So I will list the 2 on this side and take 3 minus 2, which gives me 1. So we keep on doing this, and this is how we know where to stop. When we get an answer which is a base 2 number, that's where we stop. So 1 is a base 2 number, it's 2 to the 0. So once we hit a base 2 number, we stop, we list that as our last number, and then we say we're done there, we don't go further. You know, this is a seemingly complicated way to do something easy, which is, okay, let me make more space down here, which is to write 75 as a sum of base 2 numbers. So here we'll write 75 as just the sum of all these numbers. 64 plus 8 plus 2 plus 1. It's always good at this point to check. If you add these up, do you get 75? I think we do. That will give us, yeah, so that's fine. Right. And that is the hard part done, because now we can write this number in expanded form for base 2s, right? We needed base 2s so we could do this. So I'm going to do this in a few steps so I don't lose anybody. 64 is 2 to the power something. We don't know, but we can check on our table above. It's 2 to the 6. 64 is 2 to the 6. 8 is 2 cubed. 2 is 2 to the 1. 1 is 2 to the 0. So we're just writing them as base 2 numbers. Okay. Right? You can see we're working up to expanded form here. Okay. And now the second last step is to finally write this in expanded form. And the way we do that, now this is where I need you guys to be with me, because people always ask me this one. Just be aware of what I'm doing here. Let's say this carefully. Anything that exists here, I will put a 1 in front of it. So we'll see what I mean. 2 to the 6 exists, so it gets a 1 times 2 to the 6. The 5 doesn't exist here, right? So it gets a 0. 2 to the 5 is not there, so I say 0 times 2 to the 5. Right. 2 to the 4 is also not there. So see, I'm going in order. 2 to the 4 is not there, so it gets a 0 in front of it. A 2 to the 3 is there, so it gets a 1 in front of it. Okay, next one is 2 squared, which I don't see. 2 squared is not there, so it gets a 0 in front of it. Two to the 1 is there, so it gets a 1 in front of it. And 2 to the 0 is there, so it gets a 1. And then from here, we just read out the binary number. The binary number is just the 1s and 0s in front, right? So we read this, we read like this: 1, 0, 0, 1, 0, 1, 1. That's the binary number, right? So I'll just write it here: 1, 0, 0, 1, 0, 1, 1. That is 75 in binary. You guys want to try one example like this? Can I, sorry? I can do that. All right. Okay, so I'll leave this example here. Let's do another one. I'll make space here. Okay, you gave me the number 84. I'll go with that. Okay, so number 84. Again, we always do this in the same way, is that we start listing the base 2 numbers. So I'll start listing them. What happened to my number 84? Okay. Oh, it's here. Okay. 2 to the 0, 2 to the 1, 2 squared, 2 to the 4, 5, 6, 7, 8. I'm not sure how far we need to go, but we just keep on going until we pass the number 84. So let's just check. Okay, so I'm just listing. Sorry. I skipped 3. Okay, sorry. Let's sort that out. Thank you. That's 3, 4, 5, 6, 7. Okay, again, I'm not sure how many we need. Let's check. So the first one is 1, 2, 4, 8, 16, 32, 64. What is it? 124, I think. Yeah. 128, sorry. 128. 128. So that's all we need. So 128 is bigger than 84, so we can stop. We don't have to go further with that. Okay, so I'm going to open up my calculator here just to keep checking as we go along. Okay, so the procedure again, we start with 84. First thing we do is we find the first number on this list, which is smaller than 84, right? Working from the right. The first number smaller than 84, it's not 128, so we reach 64, right? 64 is the first number we work with. So I'm going to list 64. We will take 84 minus 64. Hang on, guys, I think I can do this one. That's 20, right? Okay. I think so. I'm never sure with maths. Okay. So is everyone fine with this step here? Perfect. So then again, we keep doing the same thing over and over again. Now with 20, starting from the right, looking toward the left, what's the first number which is smaller than 20? 16. 16. Someone said 18. 16 is the number. So then we take our previous number and subtract this number. 20 minus 16. I think we're good with that one. This is actually a nice number, because we're going to stop early with it. Okay, so we got 4 as the answer. 4 is a base 2 number, so that means we can stop here. All right, we'll just list it at the bottom as our answer, and then we say X, meaning we stop here. Yeah, so as soon as we reach a number which is a base 2 number, C4 is a base 2 number, meaning it exists on this list here. As soon as we find a number that's on that list, then we stop. We don't need to go further.
What a number. You said 8. Minus 16.
Then you stop there. Yeah. Then it's much easier. Okay. Yeah. So as soon as you get that number, you stop, even if it's on the first step. Yeah. Okay, then from here we can construct our binary number. We write 84 as a sum of the numbers we found, which is 64 plus 16 plus 4. Okay, everyone still with me here?
Yeah.
Yeah, all right. It's straightforward, but a bit tedious. Okay, so we rewrite all these as base 2 numbers. 64 was, which one was it? 2 to the 6. 64 is 2 to the 6. 16 was 2 to the 4, I think, yeah. 2 to the 4, and 4 is 2 squared. So some people have the ability to look at this and work out the binary number. That's okay, but I don't think I'm there yet. So we have to just list the thing out in expanded form first. Okay. So again, I'll emphasize this because this is where most people get lost. Yeah, that depends how they ask it. So that's the thing I can't predict. So it's always safer to just write everything. So guys, if there's any doubt, just write everything. Because when you guys get your tests back, you'll see some people lost marks for very silly things. Right? I had to be a little bit strict because everyone was getting very high marks. Right, so yeah, guys, if I give it, everyone gave it 100%, it'll get moderated for sure, then it'll go down to 60%. So we'd rather do it this way, right? Probably right. Okay, so guys, let's do the final step here. So now, as I said before, anything that exists here gets a 1 in front of it. And obviously, the first one exists. We can see it. 2 to the 6 exists there, so it gets a 1 in front. 1 times 2 to the 6. Right? 2 to the 5 doesn't exist. It's not there, so it gets a 0 in front. So 0 times 2 to the 5. Yeah, and then we go in order. We start from 6, then we check 5. 5 doesn't exist. Then we go to 4. 4 does exist. 2 to the 4 does exist, so it gets a 1 in front of it. 1 times 2 to the 4. 2 to the 3, I don't see it there. So that gets a 0 in front of it. 0 times 2 to the 3. 2 squared is there, so it gets a 1 in front of it. And 2 to the 1 is not there, so it gets a 0. Sorry, I said 0 and I wrote 1. That should be a 0. 0 times 2 to the 1. And the last one is not there as well. 2 to the 0. So we always work all the way up until 2 to the 0. Because sometimes we're tempted to stop here because it's the smallest one, but you have to keep going up until 2 to the 0. Okay. So now we can just read out our binary bit or binary string. It'll be 1, 0, 1, 0, 1, 0, 0. Okay. All right. Is everyone still with me?
Yes.
Still alive?
Yes.
So are you guys going to manage to push a few more minutes and just call it off? Or do you want your break? Okay, democracy, guys. So if you want to continue, put your hands up. Continue. Okay. It's okay, guys. You can put your hands down. That's majority. Let's just see where we are in the notes because maybe.
I wasn't paying attention.
Okay, so guys, I'm going to do one more example for the same thing and then I'll give you homework. Right? I don't want to do something new while you guys are struggling. Exodus, yeah, we'll do that next time. So guys, I'm going to do the same thing now, but with a different method. Yeah. Same example, different method. Let's check if we get the same thing. And guys, this is something that you guys probably learned in high school, and I didn't. So if I make a mistake, if you guys see a better way I can do it, let me know. Okay. All right. Guys, we'll only stop in 10 minutes if I get silence, so I can do this. Right? It may be quicker than 10 minutes. That's up to you guys. Okay, so let's do the same. What example did we do? We did 75 and we know the answer. So let's do 75 again using this other method and we'll check whether we get the same answer. Okay, so some of you guys know this method, so help me out if you do know this method. 75, first you take 75 and divide by 2. And then I'm just going to use the calculator to check how this goes. 75 divided by 2. We get 7.5. Thank you. So then we'll write this as 37 with the remainder 1. Right, so if the remainder is anything other than 0, we somehow consider it to be 1. So I'll just write an arrow here and say 37-1. Because there is a remainder there. As long as there is any remainder, we write -1. If there's no remainder, we write -0. Okay. So now we do the same thing with 37. Take 37 and divide by 2. I'll do that here. 37 divided by 2. No, sorry, I'm using the same number again, aren't I? No, it's right. It's fine. It's fine. 18,5. Thank you. That's 18,5. So we write this as 18 remainder 1. I don't like using the word remainder because it's not really a remainder, but this is not 18, so the remainder, what if there's any remainder at all, we write remainder 1. Right, so it's 0.5 means there's some remainder, so we write remainder 1. Now we use our number 18, divide that by 2, the answer is 9. Right, so there's no remainder here. Right, so we'll write that as 9 with no remainder. So we just keep on doing this. Now 9 divided by 2, 4.5, which is going to be, you guessed it, 4 remainder 1. Okay, and we'll just keep going to the end. So now 4 divided by 2 gives us 2. So that's going to be 2 remainder 0. Okay. Now last one, I think. Is it the last one? Second last, sorry. 2 divided by 2 gives us 1. So that's now 1 with no remainder. I just learned this method yesterday, guys. So if you've done it before, just let me know. So the last one is 1. Keep dividing by 2. So 1 divided by 2 gives us a half. All right, this is 0.5, which is 0 remainder 1. Okay. Something wrong here. Okay, so now let's just check this. So apparently if we take this binary bit string from bottom to top, that's the answer. Okay, so bottom to top. So this here makes the, let's change color. So this makes the first one, that's a 1. This makes the second one, that's a 0, and so on. 1, 0, 1, 1. Now, is that correct according to what we did before? It is, okay. So we're fine. So let me just make space so we can see all of this here.
Specific.
I don't think so, because I went and checked the notes. It doesn't show any method at all. So use whatever you prefer. If they ask anything stupid in the test, I'll just mark as if they ask something stupid and I'll give you the marks. Okay, I shouldn't be saying all this on the video. Anyone here has any connections that work in the IIE? No, but I got some complaints. Hey, everyone done taking this down? Take pictures or whatever you need to. All good. Okay, well, I know this is a particularly taxing section on the students. So I'm going to give you guys these to try at home, right? Okay, guys, are you all listening to me? Try these at home and then we can call it off here. Then I'll see you guys next time.
Okay.